Okay, so question about two, those ones are kind of tricky. Uh, so I made up one that's similar to number two. It's just different numbers, but the same idea, just different costs for laying the pipe. In that case, I think it was an electrical wire, but it's the same idea. So what you have to do first in this case, Tia, is to kind of got to get the diagram first. So if we're thinking about where the company is, so the first thing we're going to say that, let's say that their location is here. Okay, and then we go down the road 8 kilometers. I think you have. So we go down 8 kilometers, and then at a right angle we go north. We go across a river, 3 kilometers. So up here. Okay, now what the question is asking us is if we label this a little bit, if this is our road here, and then this is the river part, and this is where the person's residence is, okay? We're going to lay pipe here, so I'll just use a different color line here. Let's go with a different orange or whatever. So I'm going to lay pipe, but I'm not going to lay it all the way down here and then go here, or I'm not going to go like this. I'm going to go down the road to a point where it's going to be cost efficient for me to cross the river like this. Okay? So that's how I'm going to lay the pipe. I'm going to go down the road because it's cheaper, but at some point I have to cross this river. So we want to minimize this cost here. So we're going to go straight to the residence across the river. It might be here, it might be here. We don't know where it is. So what we do is we define this distance from where you're going to cross from here to here as X distance. So many kilometers. We're not sure how much. So what's left? If this whole thing is 8, what's left over here from where the company is to where they cross into the river, this is what you're trying to find. This is actually the 8 kilometers minus X from here to there. Okay? So this distance, you're going to lay pipe at $3,000 per kilometer. And then this distance across here, you're going to lay pipe at $5,500 a kilometer. So this is more expensive. You're not going to lay it in this corner, but so you have to find out what this distance is. And we can do that by using Pythagorean theorem. Now we know that this is 3 kilometers across the river here. And we define this as X. So that means if you go 3 squared plus X squared, that's going to be the hypotenuse squared. So 3 squared plus X squared equals this hypotenuse squared. So that means if you want the hypotenuse, that's going to be 9 plus X squared square rooted. So that's what this distance of this hypotenuse is the square root of 9 plus X squared. So that's your distance there, and then your distance here is 8 minus X. In terms of X, and you don't know what the X is, that's what you have to find out. So how do you find cost then? Well, cost is simply the distance multiplied by the price per kilometer. So if we want cost, okay, it's going to be so much under the road, which was $3,000, times the distance, 8 minus X. Okay, then we need this under the water here, or under the river. That distance is going to be plus 5,500 times that distance, which is the square root of 9 plus X squared. And this is our cost equation. Now in calculus, and what the whole max min unit is about, is if you take a derivative, if you think of this as a curve, you take a derivative, remember whenever the derivative is the slope. So that means if you take the derivative and equal it to 0, that means you have a zero slope. A zero flat slope means that you either have a maximum, a hump, or a minimum, a low. And what we want to do is we want to get the minimum here. So we're going to use the derivative to get the minimum cost. So we have to take the derivative of this equation, set it to 0, and then we have our answer. Okay, so I'm going to say that 0 equals the derivative of cost, which we'll call C prime. So actually, before we do that, let's expand this a little bit. Let's write this in terms of something that you can do a derivative easier for. Okay, so we'll go 3,000 times 8 first. Okay, so 8 times 3, that's 24,000. Okay, and then 3,000 times negative x is 3,000, negative 3,000x. And then this we're going to write as power of 1/2 so that we can use the derivative rules of the power rule. So that when we're taking it, so it's going to be this times 9 plus x squared to the 1/2. Oop, not outside the, excuse me there. Inside the brackets, and then 1/2 outside to represent the square root. Okay, now we'll take the derivative. It'll be a little easier to take the derivative now. So we'll say that C prime, which is going to end up, we're going to equal it to 0. So this is going to be 0 because there's no x there to take the derivative of. So this is 0. This is negative 3,000 if we take the derivative of this. Okay, because it's x minus x to the 1 power minus the 1. Okay, now this, we have to do the chain rule. So we think of 9 plus x squared as the variable. Okay, so we're going to do that as a variable. So we're going to go 1/2 out front. So it's going to be plus 1/2 times 5,500 times the variable, which is 9 plus x squared, plus the chain rule, plus 1/2 subtract 1. 1/2 subtract 1 is negative 1/2. Okay, and then we have to do the chain rule. What's the derivative of 9 plus x squared? Derivative of 9 is 0. Derivative of x squared is 2x. So we'll put 2x. So that's our full derivative. Okay, so now we have to try to solve for x in this equation. Okay, so this is 0 equals. Okay, this is equal to 0, and that's 0, so we'll just eliminate it. Negative 3,000. Okay, and then we're going to go 2x times 1/2 is x times 5,500. So we have plus 5,500x to the power of, and then x plus, or 9 plus x squared to the power of negative 1/2. Okay, now we can move the 3,000 over to the other side and make it positive. And then we can write this back into the fraction form. So this is a negative exponent. So if we want to make it positive, we have to move it to the bottom of the fraction. So we make a bottom, and we move it to the bottom. Exponent rules from, I forget, pre-calc 20, I think. So then this would be to the 1/2. Now, we can also say that 1/2 is back to a root now. Okay, so now you cross multiply here. So you got 3,000 times the square root of 9 plus x squared equals 5,500x. Okay, now to solve this, Tia, all you have to do is divide both sides by 3,000. So take your calculator out here and go 5,500x divided by 3,000. Okay, when we do that, we get 1.833333. So I'm going to just leave that on my calculator for now. But we're going to get the square root of 9 plus x squared equals 1.833, etc. x. Okay? Now we're going to square both sides. So take this number and square it. Okay, so I get 3.361. So this is going to be 3.361 361x squared, because I squared it. And when we square this, it eliminates the root sign. So it's 9 plus x squared. So now we're going to collect all the x squareds to the right side. So that means on the left side, we're going to have to subtract 1x squared from both sides. So if we subtract 1x squared, we get 9. If we subtract from 3.361 x squared and we subtract 1x squared, you're left with 2.361 x squared. Okay, and then we solve by dividing 9 by 2.361 to get x squared. So you go 9 divided by 2.361 equals, and you get 3.81, we'll say, 3.81 equals x squared. So 3.81 equals x squared. Then we square root that to get x. Okay, oops, got that one wrong there. Put not cube root, square root. So square root of 3.81 is 1.95 approximately. So we can say that this is 1.95. So that means if we go back up to our diagram here, that this is 1.95 kilometers. And then this would be 8 minus that. So 8 minus 1.95 is 6.05 kilometers from here to here. So, and that would add up to 8 when we add that other one. So the question was asking us, right here, it says, blah, 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 the cost of laying the pipe, blah, blah, blah. And it says, find the point along the road that the company will cross into the river to minimize the cost of the pipe. So they're going to cross into the river 6.05 kilometers down the road. And that would be our answer. So you would say 6.05 kilometers down the road. Okay, those ones are kind of tricky ones to do. So hopefully that'll help you with the one that is on the hand in. I'll send you this here video right away. It might take a bit to download, but I'm going to send it to you right away. And good luck.